What is the steady flow energy equation for energy transformation? Imagine a stream of water flowing through a pipe, constantly moving without stopping. How does the energy of that water change as it moves? That's what the steady flow energy equation helps us understand. It's a way to see how energy is conserved and transformed in systems where fluid flows steadily, like turbines, pumps, or nozzles. This equation is based on the first law of thermodynamics, which says energy can't be created or destroyed, only changed from one form to another. In simple terms, the steady flow energy equation balances the energy coming into and going out of a control volume, which is just a fancy way of saying a specific part of a system. It considers heat transfer, work done by or on the fluid, and the energy stored in the fluid itself. The energy forms we look at include enthalpy, which combines the internal energy of the fluid and the flow work, kinetic energy related to the fluid's speed, and potential energy related to its height or elevation. The equation is written as the heat added to the fluid minus the work done by the fluid equals the change in enthalpy plus the change in kinetic energy plus the change in potential energy. To put it simply, if you add heat to the fluid or do work on it, the fluid's energy increases. If the fluid does work or loses heat, its energy decreases. The equation uses specific terms for each of these energy changes, with subscripts 1 and to indicating the inlet and outlet points. For example, in a heater, no work is done by the fluid, so the heat added increases the enthalpy. In a turbine, no heat enters or leaves, so the energy decreases as the fluid does work. In a nozzle, the fluid's speed increases, meaning its kinetic energy goes up, while its enthalpy drops. This equation helps engineers figure out how energy moves and changes in these devices, making sure everything works efficiently and safely. So, in essence, the steady flow energy equation is a practical way to see how energy is transferred and transformed in systems with continuous fluid flow. It's a direct application of the first law of thermodynamics, broken down into simple energy terms. This makes it easier to analyze and design machines like turbines, compressors, and heat exchangers, ensuring they operate smoothly and effectively.